When calculating the load for track lighting, it is essential to adhere to the National Electrical Code, specifically Section 220.12 IP. This section addresses the requirements for calculating the load for track lighting, especially when dealing with continuous loads. The code mandates that continuous loads be multiplied by 125% when determining the service and feeder demand. This ensures that the electrical system can handle the sustained load without any issues. Let's delve into the specifics of why this calculation is necessary and how it is applied. The primary reason for the 125% multiplier is to account for the continuous nature of lighting loads. Continuous loads are defined as loads that operate for 3 hours or more at a time. Track lighting often falls into this category, especially in commercial or retail settings where the lights are on for extended periods. By applying the 125% multiplier, the code ensures that the electrical system is adequately sized to handle the continuous load without overloading or overheating. Now let's consider a practical example. Suppose you have a track lighting system with 45 heads, each equipped with a 50-watt lamp. The total connected load for the track lighting is 45 heads multiplied by 50 watts per head, which equals 2250 watts. However, according to NEC 220.12, you need to multiply this load by 125% to account for the continuous nature of the lighting. Therefore, 2250 watts multiplied by 1.25 equals 2812.5 volt amps. This means that even though the actual load is only 2250 watts, you need to add 2812.5 volt amps to your service and feeders to comply with the NEC requirements. It is important to note that this calculation applies to both the service and feeder conductors. The service conductors are the wires that bring power from the utility company to the building, while the feeder conductors are the wires that distribute power from the service panel to the various loads within the building. Both sets of conductors must be sized to handle the increased load due to the 125% multiplier. Now let's consider another example to illustrate the application of NEC 220.12 IP. Imagine a retail store with 300 feet of track lighting, each foot containing a 50-watt lamp. The total connected load for the track lighting is 300 feet multiplied by 50 watts per foot, which equals 15,000 watts. According to NEC 220.12, you need to multiply this load by 125% to account for the continuous nature of the lighting. Therefore, 15,000 watts multiplied by 1.25 equals 18,750 volt amps. This means that even though the actual load is only 15,000 watts, you need to add 18,750 volt amps to your service and feeders to comply with the NEC requirements. The NEC provides specific guidelines for determining the ampacity of conductors based on the calculated load. Ampacity refers to the current carrying capacity of a conductor. The NEC tables, such as Table 310.15b16, provide information on the ampacity of conductors based on their size, insulation type, and installation method. When sizing conductors for track lighting loads, you must ensure that the conductors have sufficient ampacity to handle the increased load due to the 125% multiplier. In addition to sizing the conductors, you also need to consider the overcurrent protection for the track lighting circuit. Overcurrent protection devices, such as circuit breakers or fuses, are designed to protect the conductors from overloads and short circuits. The NEC specifies the maximum overcurrent protection rating for conductors based on their ampacity. When selecting overcurrent protection devices for track lighting circuits, you must ensure that the devices are properly sized to protect the conductors from overloads and short circuits. Furthermore, it is important to consider the voltage drop in the track lighting circuit. Voltage drop refers to the decrease in voltage along the length of a conductor due to the resistance of the conductor. Excessive voltage drop can cause the track lighting to dim or malfunction. The NEC recommends limiting the voltage drop to 3% for branch circuits and 5% for feeders. When designing track lighting circuits, you must calculate the voltage drop to ensure that it does not exceed these limits. To minimize voltage drop, you can use larger conductors or reduce the length of the circuit. It is also important to consider the type of track lighting system being used. There are several different types of track lighting systems available, each with its own unique characteristics and requirements. Some track lighting systems use low voltage lamps, while others use line voltage lamps. The type of track lighting system being used will affect the load calculation and the selection of conductors and overcurrent protection devices. When working with low voltage track lighting systems, it is important to consider the transformer losses. Transformers are used to step down the voltage from the line voltage to the low voltage required by the lamps. Transformers are not 100% efficient, and some energy is lost in the form of heat. These losses must be taken into account when calculating the load for the track lighting system. Additionally, it is crucial to ensure that all electrical work is performed by qualified and licensed electricians. Electrical work can be dangerous, and it is important to follow all safety precautions to prevent accidents. Qualified electricians have the knowledge and experience to perform electrical work safely and in accordance with the NEC. The NEC is constantly evolving, and it is important to stay up to date on the latest changes. The NEC is updated every 3 years, and each new edition includes revisions and additions to the code. It is the responsibility of all electrical professionals to stay informed about these changes and to ensure that their work complies with the latest requirements. In summary, when calculating the load for track lighting, it is essential to adhere to NEC 220.12 and multiply the continuous load by 125%. This ensures that the electrical system is adequately sized to handle the sustained load without any issues. Remember to consider the ampacity of conductors, overcurrent protection, voltage drop, and the type of track lighting system being used. By following these guidelines, you can ensure that your track lighting installation is safe, efficient, and compliant with the NEC. Always consult the latest edition of the NEC and consult with a qualified electrician for any questions or concerns regarding electrical installations. Neglecting to properly calculate the load and size the conductors and overcurrent protection devices can lead to serious consequences, including electrical fires and equipment damage. By taking the time to understand and apply the NEC requirements, you can ensure the safety and reliability of your electrical system. The information provided here is for general guidance only and should not be considered a substitute for professional electrical advice. Always consult with a qualified electrician before performing any electrical work. Now let's consider a more complex scenario involving multiple track lighting circuits. Suppose you have a commercial space with 3 separate track lighting circuits, each serving a different area of the store. Circuit 1 has a connected load of 1000 watts, Circuit 2 has a connected load of 1500 watts, and Circuit 3 has a connected load of 2000 watts. To calculate the total load for the track lighting, you need to add the loads for each circuit together. Therefore, the total connected load is 1000 watts plus 1500 watts plus 2000 watts, which equals 4500 watts. According to NEC 220.12, you need to multiply this total load by 125% account for the continuous nature of the lighting. Therefore, 4500 watts multiplied by 1.25 equals 5625 volt amps. This means that even though the actual load is only 4500 watts, you need to add 5625 volt amps to your service and feeders to comply with the NEC requirement. When dealing with multiple circuits, it is also important to consider the load balancing between the phases of the electrical system. Load balancing refers to distributing the load evenly across the different phases to minimize imbalances. Imbalances can cause voltage fluctuations and other problems with the electrical system. The NEC provides guidelines for load balancing, and it is important to follow these guidelines when designing track lighting circuits. In addition to the NEC requirements, it is also important to consider any local codes or regulations that may apply to track lighting installations. Local codes may have additional requirements or restrictions that must be followed. It is the responsibility of the electrical contractor to be aware of and comply with all applicable codes and regulations. Furthermore, It is important to use high-quality materials and equipment when installing track lighting. Low-quality materials and equipment can fail prematurely, leading to safety hazards and costly repairs. Always use materials and equipment that are listed and labeled by a recognized testing laboratory, such as Underwriters Laboratories or electrical testing laboratories. Listed and labeled products have been tested and certified to meet safety standards. When installing track lighting, it is also important to follow the manufacturer's instructions carefully. The manufacturer's instructions provide detailed information on how to install the track lighting system properly and safely. Failure to follow the manufacturer's instructions can void the warranty and create safety hazards. It is also important to perform regular maintenance on track lighting systems. Regular maintenance can help to identify and correct potential problems before they become serious. Maintenance tasks may include cleaning the track lighting fixtures, replacing lamps, and inspecting the wiring for damage. By performing regular maintenance, you can extend the life of your track lighting system and ensure its continued safe operation. In addition to the technical aspects of track lighting installations, it is also important to consider the aesthetic aspects. Track lighting can be used to create a variety of different lighting effects, and it is important to choose the right type of track lighting and the right placement of the fixtures to achieve the desired effect. Consider the color temperature of the lamps. Color temperature refers to the warmth or coolness of the light. Warm light has a yellow or orange tint, while cool light has a blue tint. The color temperature of the lamps can affect the overall mood and atmosphere of the space. Choose lamps with a color temperature that is appropriate for the application. Also, consider the beam angle of the lamps. The beam angle refers to the width of the light beam. Narrow beam angles are used for accent lighting, while wide beam angles are used for general lighting. Choose lamps with a beam angle that is appropriate for the application. Another important consideration is the dimming capability of the track lighting system. Dimming allows you to adjust the brightness of the lights, which can be useful for creating different moods and atmospheres. If you plan to use dimming, make sure that the track lighting system and the lamps are compatible with dimming controls. When selecting track lighting fixtures, consider the style and finish of the fixtures. The fixtures should complement the overall design of the space. There are many different styles and finishes available, so you should be able to find fixtures that match your taste. It is also important to consider the energy efficiency of the track lighting system. Energy-efficient track lighting systems can save you money on your electricity bill and reduce your carbon footprint. Look for track lighting systems that use energy-efficient lamps, such as light-emitting diodes or compact fluorescent lamps. In addition, use occupancy sensors or timers to turn off the lights when they are not needed. In conclusion, track lighting installations involve a number of important considerations, including NEC compliance, load calculation, conductor sizing, overcurrent protection, voltage drop, aesthetics, and energy efficiency. By carefully considering these factors, you can ensure that your track lighting installation is safe, efficient, and visually appealing. Always consult with a qualified electrician before performing any electrical work, and always follow all applicable codes and regulations. The NEC requirements are in place to protect people and property from electrical hazards, and it is important to take them seriously. Remember that the 125% multiplier for continuous loads is a critical factor in ensuring that the electrical system can handle the sustained load of track lighting without any issues. By following the guidelines outlined in this discussion, you can confidently design and install track lighting systems that meet the highest standards of safety and performance. The key takeaway is to understand that the NEC provisions, such as 220.12 are not arbitrary rules, but rather carefully considered measures to prevent electrical hazards and ensure the reliable operation of electrical systems. By adhering to these provisions, you contribute to a safer and more efficient electrical environment. Now, to recap the key points regarding track lighting load calculations and NEC compliance. Firstly, always refer to the latest edition of the National Electrical Code for the most up-to-date requirements. Secondly, understand the definition of continuous loads and how they apply to track lighting systems. Thirdly, apply the 125% multiplier to continuous lighting loads as specified in NEC 220.12. Fourthly, ensure that conductors are sized appropriately to handle the increased load due to the 125% multiplier, consulting NEC tables for ampacity ratings. Fifthly, select overcurrent protection devices that are properly sized to protect the conductors from overloads and short circuits. Sixthly, calculate voltage drop to ensure that it remains within acceptable limits, using larger conductors or shorter circuit lengths to minimize voltage drop. Seventhly, consider the type of track lighting system being used, whether it is low voltage or line voltage, and account for transformer losses in low voltage systems. Eighthly, engage qualified and licensed electricians to perform all electrical work, ensuring that they follow all safety precautions and comply with the NEC. Ninthly, stay informed about changes to the NEC and any local codes or regulations that may apply to track lighting installations. And tenthly, use high-quality materials and equipment that are listed and labeled by a recognized testing laboratory. By keeping these key points in mind, you can ensure that your track lighting installations are safe, efficient, and compliant with all applicable codes and regulations. The investment in proper planning and execution will pay off in the long run, providing peace of mind and a reliable lighting system.